Hello geometry students, here's your lesson for section 4.2, classifying triangles with Missy McCarthy, math instructor at Okemos High School. By the end of this lesson you should be able to say that I can classify triangles by their angle measures, I can also classify triangles by their side lengths, and I can use triangle classification to find missing angle measures and side lengths. So we're going to define a triangle first, and our definition for triangle is going to be a polygon with 3 sides. Triangles can be classified in 2 different ways. They can be classified by their angle measures, and they can also be classified by their side lengths. So the side lengths of this triangle are segments AB, segments BC, and segments AC, and they make up triangle ABC, where A, B, and C are what we call the vertices of the triangles. It always baffles me that we call these triangles, but then we say they have 3 sides. I think we should either call them trilaterals, because lateral means sides, or we should call them tri-sides. I don't know, but we call them triangles and then say they have 3 sides, or we should call them triangles and say they have 3 angles, but whatever. All right, so the way that you classify triangles by their angles is in 4 different ways. The first way right here is an acute triangle. And acute triangles are triangles where all 3 angles are acute. Okay. If we have a triangle that is equiangular, that means all 3 angles in the triangle are equal. Now they're also acute, so this would also be an acute triangle, but more specifically a better name would be equiangular, because in the acute triangle that doesn't necessarily mean that all 3 angles are the same, but in an equiangular triangle it does. The next classification is a right triangle, and that just means that you have 1 right angle. And then the last classification would be an obtuse triangle, and that just means you have 1 obtuse angle. So those are the 4 ways in which you can classify a triangle by its angle measures. Now you can also classify a triangle by its side lengths. So here are the 3 ways that you can classify a triangle by its side lengths. First would be equilateral. Again, remember I just told you in that previous slide that lateral means sides? That means equal sides. 3 congruent sides would make for an equilateral triangle. The second would be isosceles triangle. Now many people miss this. Isosceles means at least 2 congruent sides. At least 2 congruent sides. So this triangle that has 3 congruent sides is actually also isosceles because it's at least 2, not exactly 2. But if there is 2, the better name would be isosceles. If there is 3, the better name would be equilateral. And then the last is a scalene triangle. And a scalene triangle means that you have no congruent sides. Notice there are no congruent markings on that triangle. Alrighty, so we're going to classify the following triangles by their angle measures this one is asking for. So I'm going to trace out triangle BDC. Triangle BDC is this purple triangle right here. So I have to see if I know anything about their angle measures. Well, I know that that angle right there is 100 degrees. I know that this angle right here is 10 degrees. And I don't know this one, but I do know that it's less than 90. So this has one obtuse angle, this 100-degree angle right here. So I am going to say this is an obtuse triangle, 1 obtuse angle. All right, I'm going to erase that, and I am going to trace out angle ABD. Angle ABD is that one right there. I know this angle is 20 degrees and that angle is 80 degrees. I don't know what that one is there, but I know it is these 2 right here are supplementary, and if this is 100, I actually do know that that one is 80. Because of the linear pair theorem, this linear pair is supplementary. So if this is 100, then the one on the inside is also 80, which means that all 3 angles are less than 90, so this would be an acute triangle. Triangle ABD is acute. Alrighty, now we got some triangles we're going to classify by their side lengths. So if we look here, the first one we're going to do is triangle EHF. EHF. That's this triangle right here. And I noticed that we got congruent marks here and here, and those are both 10, and that's 12. So this is an isosceles triangle. Isosceles triangle. Alrighty, next we are going to look at triangle EHG. EHG, that's the big triangle there. I know this side is 11. See that there? This side is 12. I see that there. This total side is 10 plus 4, so this whole side is 14. They are all different, which makes this a scalene triangle. So we just practiced first two I can statements. I can classify triangles based on their angle measures, and I can classify triangles based on their side lengths. All right, here's the last I can statement. I can use triangle classification to find missing angle measures and side lengths. So clearly here, because of these markings, we have an isosceles triangle, which means those side lengths are congruent, so we can set them equal to each other to find x. So I can do 4x minus 10.7 equals 2x plus 6.3. I'm going to subtract 2x from both sides, and I get 2x minus 10.7 is equal to 6.3. I'm going to add 10.7 to both sides. Oops, 6.3. And I get 2x is equal to 17. Divide both sides by x, and x is going to be half of 17 is 8.5. Okay, so now could I plug that in and find all three side lengths? Yes, I could find JK by doing 4 times 8.5 minus 10.7. I know that KL is going to be the same as whatever JK is. Same as JK because they are congruent. And then I can find JL by doing 5 times 8.5 plus 2. So I'm going to assume that you guys can do that calculation and find the side lengths. All right, lastly, we got a steel mill produces a roof supports by melting pieces of steel beams into equilateral triangles. All right, so there is our vocabulary word, 3 equal sides. Each side of the triangle is 18 feet long. So they're making these supports, and they are 18, 18, and 18. How many triangles can be formed if they have a total of 412 feet of steel beam available? Well, one triangle would have a perimeter of 3 times 18, and that would give us 54 feet for one triangular beam. Okay, so how many of those can we make if we have 420 feet available? So now I would do 420 feet divided by 54 to see how many of those we can make. 420 divided by 54 is approximately 7.78. So we can make at most 7 beams. We do not have enough to make 8 beams. Alrighty, so ask yourself the question, can you do those classifications, and can you use the classification to find missing angles and side lengths? We will see if you can in class. Hasta luego.